different domains within the kindergarten standards. We're going to talk about counting and cardinality, and then operations and algebraic thinking. Um, but first I wanted to talk about why are we using manipulatives. There's three different stages that children go through when we're learning something new. And ideally, we're going to start with manipulatives in the concrete stage. And we use manipulatives in the concrete stage as a way to introduce concepts, and children are able to explore and develop their own ideas before we start giving them algorithms. So they're able to identify patterns and see how things work, make their own justification first. Then we're going to move on to the representational stage, where we're going to use pictures to replace concrete objects. So children can now demonstrate visually and communicate their ideas at a picture level. And then finally, as children get older, almost in the more middle school age, we're going to use symbols like numerals, operation signs, and variables so that children can now demonstrate their understanding of math concepts using actual math language. So all three of these stages are important to the learning. So with counting and cardinality, there are, and with any of the grade levels that we're going to talk about, there are an infinite number of ways in which we can incorporate manipulatives into kindergarten math, first grade math, second grade math, etc. The more that we can incorporate a variety of manipulative ways, the more ways we'll be able to show a larger magnitude of these representations so that students have an opportunity to choose a way that makes sense to them. Students need to develop a strong number sense by being able to relate numbers visually, verbally, and in written form. So some common manipulatives that are used in counting cardinality are objects for counting. These could be little number bears, coins, little figurines, anything that they can count. We're going to use 5 frames and 10 frames, hundreds charts, dot cards, and numeral cards. So this is the domain here for counting and cardinality. Students need to know number names and the count sequence, count to tell the number of objects, and then compare numbers. So I'm going to go through each of the specific standards and note that many of the techniques that we're going to talk about cover a variety of different standards, not just one in particular, which is awesome as well. And then it also jumps between domains as well. So let's start with our hundreds chart. Students need to be able to count from 1 to 100 by the time they leave kindergarten. They need to be able to count by tens. They also need to be able to count forward and backward from any given number. Students should be counting every day in a variety of different ways. Some common questions to ask might be, what number comes after 4? What number comes after 55? Or what number comes next? So if we stopped at 38, what number comes after 38? What number comes before 38? Count backwards 3 spaces from 46. Count forward 5 units from 51. And simply you would just sit in front of a classroom and you would just go through a series of questions every single day until students almost have it memorized. Students should also be writing their numbers every day. Remember that you have all year to master all of these different standards. So don't feel overwhelmed by the standards that you need for language arts, for reading, for art, whatever the standards that you're following, you have all year to accomplish them. So start small. Don't overwhelm the students at all. So start with a single number at a time and gradually build. So start with the number 0. Start writing that every day, practicing it. When students got it, then work with 0 and building on to 1, and so forth. Some great activities to bring everything together. So some great manipulatives for counting. On the top left corner, you see we have number dots with numeral cards. You can use clothespins to represent 3. So they see the numeral 3, they see the dot representation, and then they're building 3 themselves. They're using little puff balls for the number 5. We see the numeral 5. They're placing the puff balls on the dots, so they're connecting the 2 together. Similarly with the glass beads, we have the number cards with the dot cards, and they're building their own so they can see how many. On the bottom left and on the top right here, we see we have tens frames, and we're going to get to tens frames here in a second on what that means. But notice that they're building numbers by seeing numbers, organizing numbers with chips, with clothespins, with glass beads, etc. So some common questions you might ask students: what number is this? Show me this many fingers. How do you know how many fingers to hold up? Is there another way we can show, let's say, for example, the number 5? On the bottom left here, we've got 5 dots, and then we have 5 chips lined up along the top. Is there another way we can show 5? So maybe they might bring the puff balls, etc. So asking and repeating the same questions, just asking differently and about different properties of numbers, is key to kindergarten. 10 frames may be new for some, but tens frames are awesome, and we're going to use them a lot in kindergarten, first grade, because they help develop place value. Students can start to see number relationships and patterns, especially when we start to add to 10, or when we use double 10 frames when we want to add to 20. And it helps them count because they can visually start to see patterns, what 3 looks like, what 4 looks like, what 8 looks like. Or how about 9 down in the right-hand corner? Well, they can quickly see that 1 is missing, so there must be 9 there. So they're adding and subtracting and noticing patterns without actually knowing that that's what they're doing. So let's talk a little bit more about the relationship between equality here. So I've got 2 students that set up their cubes as follows. And you might ask the questions, what does the shape on the left look like to you? And students can use their imagination. Again, there's no right or wrong answers. Count how many there are. Well, how do you know that's how many there are? So a student would count 1, 2, 3, 4, 5. Well, I know there are 5 there because the number stops at 5. And then it's also key to practice writing. So the student would write 5 below. What does the shape on the right look like to you? So they may say a letter, they may say some other figure. We'll count how many there are. So a student would count 1, 2, 3, 4, 5. Well, how do you know that's how many there are? Again, because I can, we stopped counting at 5, there must be 5 there. So then again, we would write 5 below it. Others, how are the shapes alike? How are the shapes different? So compare and contrast is also important because although their shapes are different, they still contain 5 objects. So let's say I have these clip cubes together here, and I can say that there are 5 red ones and count that there are 5 green ones. We can also talk about position. So when I look at the red cubes starting on the left, we have first, second, third, fourth, fifth. And we can do the same with the green cubes. First, second, third, fourth, and fifth. Then what if I take one of my green, unclip it, and click it to the bottom of my red train? I can ask questions like, what is the color of the first cube? Well, the first cube, when I count first, second, third, etc., is green. What is the color of the last cube? The color is red. What color is the fifth cube? So then students would have to count first, second, third, fourth, fifth. I see the fifth cube is red. Let's say that we put them back together. Let's replace the second and the fourth red cube with green cubes. So giving the students a moment, they're going to have to decompose and recompose the numbers in order to do this. So I look and I replace the second cube with the green. So I have first, second, third, in the fourth position I need a green, and then I can stack the rest of my 5 cubes on top. Flip it over. Are the second and fourth cubes green as well? Well, we see when I flip it over, when I count from the left again, first, second, the second is a red cube. Third, fourth, the fourth one is a green cube. Fifth, sixth, but in this situation, the sixth one is green, which answers what are the positions of the green cubes. So let's also say I have a set of pattern blocks here, and let's line them up in a one-to-one correspondence such that there is one yellow square for each blue diamond. So I did that for us here. And let's count them. So I have 1, 2, 3, 4, 5, 6, 7, 8 yellows. So I wrote 8 next to it. And I have 1, 2, 3, 4, 5, 6, 7 blues, which I wrote next to it as well. Determine which group has more and explain how you know. So I'm going to take away 1 yellow and 1 blue set until we don't do that any longer because we don't have an equivalent amount left. And we will see that there is 1 yellow remaining. So therefore, there must be more yellow than there are blue because we had 1 left over. After counting and cardinality, we'll move on to operations and algebraic thinking. So we need to understand addition is putting together, so composing, and understand subtraction is taking apart or decomposing numbers. So some common manipulatives used would be objects for counting, 5 frames, 10 frames, hundreds chart, dot cards, numeral cards, part, whole chart, place value chart, dice, and spinners. So we're going to walk through some manipulatives that we can use to work with operations and algebraic thinking. Again, as a reminder, what I'm showing you is not the only way to go about teaching children how to do these. We're looking at some manipulatives that we can use to spark some ideas and some interest and kind of get a feel for what kindergartners might experience. So the ability to compose and decompose objects in many different ways is crucial in this cluster. So students may first start to use their fingers at first to count by adding numbers together, or clapping sequences. So if I were to clap, students would have to remember that I clapped once, twice, 3, 4 times, then another for a total of 5 times. So adding some movement to it is helpful. So students will use concrete materials to model how numbers through 10 are composed together in a variety of different ways. They will describe their models using pictures, words, and numbers with emphasis on appropriate terminology. Students should be able to match their own models with expressions provided by the teacher. So our first example here on how we can use manipulatives, I'm going to go to the website where I got this from, and we're going to need to roll a die and see where the frog goes, and then we'll go from there. So to get to the particular manipulatives I used, I have a link on our website. So I'm just going to move my screen over so we can see here. I'm also going to pull up a virtual dice so that we can roll our dice here. Okay. All right, so I'm going to start. Okay, here's my frog, and we're starting at 0. I'm going to roll my dice, and I get a 2. So I will hop twice. So now I'm at 2. And I will write that number down as part of our lesson. We will write down 2. I'm going to roll again. I get a 4. So from here, I'm going to move my frog once, twice, 3, 4 times. And then I can write the number sentence. 2 plus 4 gives me 6. I would start all over, and I would have students do this a multiple of different times, many different times, as perhaps part of a station. And so I've got our number sentence here. Another idea, this time with subtraction, is I will start with 6 connect cubes together. I will roll the die to see how many we will take away, and I will physically take away individually that number of cubes to see what is left. So students are always seeing, touching, feeling, and it's a great way to help build number sense. And I would have them start with 6 minus something, whatever number we re-rolled, and then that's what's left over is the number of cubes that we still have connected in our hands. As you're reading books with students, picture books, regular books as part of the language arts piece, you could easily make math lessons from them. So as part of a story problem, some real life application for them. So I took this page from May I Have a Cookie Please by Jennifer Morris. You may ask the students, how many cookies do you see? What if how many cookies would be left if Alfie eats a cookie? So now we're thinking a little abstractly. Alfie were to take one and eat a cookie, how many are left? What if Alfie eats two cookies? You could take it a step further. What if Alfie's mom brought 3 more cookies? Or what if Alfie's mom took a cookie? There are many different ways that you can compose and decompose, add, subtract when you're in a book. Always bringing those skills back for students. Another way to think of building is we need to know how many more do I need to make 10, because we need to build to 10. So if I were to have 9 cubes together, how many more do I need to make 10? So let's talk about what that might look like. So let's say I have 9, line them up. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9. How many more do we need to build to 10? We need to clip another one on to build to 10. You could do, if I have 1, 2, 3, 4 hooked together, how many more do I need to get to 10? So then they would need 6 more to build to 10. All right, so let's also talk about in number frames. Let's do a 10 number frame here. Let's say I have 5, or I suppose we have 3 dots, excuse me. 1, 2, 3. How many more dots do we need to build to 10? So students say, well, we need 2 more on the top, and we need 5 more on the bottom, for a total of 7 red dots to get to 10. So asking these same types of questions over and over and over again in a variety of different ways helps students understand patterns, adding, subtracting, etc. So what I'd like you to do is pause our video and go into the lesson and watch video 1, which is found just below our lesson in Moodle, and come back and finish listening to our lesson video. So pause this and watch that one real quick and come back. After watching video 1, I want you to think of some possible questions for addition and or subtraction you could use while watching that video. A moment to pause here and there within the video to make it an interactive experience for students. Within story problems such as the one you just listened to and watched, we need to avoid keywords that we are so used to saying, such as sum automatically means addition. Modeling is the key here. Understanding what is happening, digesting number sense, that is the goal. So let's say there were 2 children playing on the swings at recess. There was 1 child playing on the slide. How many children were on the playground in all? So I clicked on virtual manipulatives, which brought me to this website. I clicked kindergarten, and under manipulatives, I clicked part whole here, because I know that there are 2 children playing on the swing set and 1 child playing on the slide. So 1 part, 2 part. So if I were to put them all together, we have a total of 3 children playing together. Michaela's teacher reads 3 stories to the class before snack time. After recess, her teacher read 2 stories. How many did they read all together? Again, Michaela's teacher reads 3 stories to the class before snack time. After recess, her teacher reads 2 stories. How many stories did her teacher read all together? So another part whole. She read 3 stories before recess, and then she read 2 stories after recess. So if we were to put them all together, we can count and see that there are 1, 2, 3, 4, 5 stories all together that the teacher read. Marco's teacher put 5 teddy bears on the shelf. Then she took 2 teddy bears away and put them in a basket. How many were on the shelf? So I know that there are 5 on the shelf. So let's represent just this area here as 5 on the shelf. She took 2 teddy bears and she put them somewhere else. So then on my shelf, I see I have 3 teddy bears left. So we ended up having a subtraction story, and we don't even really realize that it's called subtraction. But we definitely would want to write the numbers, write the sentences so that students can see and put them together. You can go ahead and read the remaining and practice more on your own so you can see how story problems would look. Another great idea is called shake and spill, where we would have between 5 and 10 two-color counters. So on one side of the counter is red and the other side is yellow. So have students work together or individually. Shake the counters in their hands or cup, probably a cup would be better, and spill the counters on their table. You can then record how many there are of each color showing and write that as a sum. So if I had 10 counters in there, obviously all of those counters together would add to 10, but we would be able to see the decomposition of numbers that build to 10 in a variety of different ways. We could have 2 yellow and 8 red, or 2 red and 8 yellow, but it all means the same. Do this several times with several different types of counters or numbers of counters. Another great way to build to 10 would be to have students draw spots on the dog that build to 10. So putting 2 spots on the left and then 8 spots on the right one, and asking key questions such as, how do you know that there will be 10 spots? Well, we know that there are multiple ways to build to 10 outside of just the 3 choices here. So ask students to compare, are there any other ways that we can share 10 spots?